Okay, folks, we're going live now. So we're looking today at the circle theorems examination style questions. The students have just had a go at this paper for the last 40 minutes, roughly. Now we're going to be looking at how we try these and do the questions using examination techniques and language. So this is our paper. Okay, let's move forward. Right, here's question number 1. The question states, so it gives us an ABCD is a cyclic quadrilateral within a circle, center 0. XY is the tangent to the circle at A, XY is the bottom. Okay, XY is the tangent to the circle at A, angle XAB, so it's just basically describing XAB is 58. This way that they've mentioned the angles is how we are going to mention them as well. So angle XAB is talking about the line, the point X to A to B and the angle in between it, which is the A1. So that's 58 degrees. That's how we're going to have to describe when we do our explanation. Angle BAD, which is B to A to D, which is the angle in the middle, the A angle in between the B and the D. I'll give you 78. And that's the angle there. Okay, we can see that now. Oh, alhamdulillah. It says, prove that AB is parallel to CD. So AB is this line here, and CD is that line there. In order for us to prove that something is parallel, what do we know about angles? Let's have a look. If you want to show something is parallel, then one thing that we can show is that if, for example, this angle here is equal to this angle here. So if these two angles are equal, that will be a proof that we have parallel lines, and they are called alternate angles. Alternate angles are always equal. So that's what we need to move towards. That's why we can show that this line is parallel to that line. So that's what we have to show. Okay, let's first of all start with what we do know. Now, angle DAY. Okay, let's use the highlighter yellow. So we have angle, so here's D, so we come along here, and we have DAY, the angle there. What can we say about this angle over here? Somebody give me a mathematical rule for angle DAY, then we'll write something down. So let's come off this now. Right. Okay, so what can we say? We say angle, which we show like this, angle DAY is equal to what? What is angle DAY equal to? It's equal to, now we're going to do working out over here. So it's 180 now. What do we know about angles which are at a point on a straight line? Okay, remember the key word here is angles at a point on a straight line. So we start from here and we go all the way around here, and we're starting at that point there. So these three angles, including the one we're looking for, must add up to 180. Good. So we say 180 degrees. Okay, and if we minus the 58 and we minus the 78, will give us the angle DAY. Okay. Now, so what is angle DAY? What is 180 minus 58 minus 78? That will give us an answer of, what did everybody get for that calculation? 44. So in the examination, we need to do the calculation. We need to make a statement that this angle that we're looking for over here is 44 degrees. And now we need to give a reason. So the reason for that is, so what do we say? What do we say for that? We say angles at a point, remember the point, at a point on a straight line, add up to, straight line, add up to 180 degrees. So that's the explanation behind this. This is what we said here was 44. Okay, so we can now label that as 44. Right, now I'm going to rub off this yellow line here. I'm going to look at something else. Okay, I'm going to see a different color. Now, if this is 44, if this is 44, what else on this diagram is also 44? Watch my line. So I'm going to go over what we just used. Now I'm going to use that again. And I'm going to go down here. And then I'm going to do what you call this last part? Z-flick. Now, Z-flick is just the way I describe it, but mathematically, when we describe that, okay, so what do we say next? Okay, let's get a brush back. Okay, so that was the first bit of explanation. Second bit of explanation. Now we have to explain this angle here. This angle here, we call it ABD. So we can say angle ABD is equal to 44 degrees, which is equal to angle YAD, or angle DAY as we explained earlier. And why is that? So what we say here is, okay, we have to write all of that down. So the angle, so here comes the explanation now for that. So the angle between a tangent where's the tangent? I'm going to put mine in brackets. My tangent YA and a chord where's the chord? The chord is, which part is the chord? The chord is, that's the chord of AD. Okay, equals the angle in the opposite segment. And which angle is in the opposite segment? Which is the one we just looked at, angle ABD. Brackets. So we've been very, very precise here on our mathematics. So we explained this angle here. We've explained this angle, how we got that. From that one we explained how that one also became 44 as well. So I'm going to label that in there now. Okay, make sure you copy all that down. Okay, remember what we said before. We have to show that this angle and this angle are equal in order to prove that the line BA and CD are parallel. So we managed to work out what this angle here is. 44, because that one's 44. Okay, so we've done those two bits of mathematics. Let's do some more mathematics. Let's clear this page here, because we need a clean page. Okay, let's put it around there. So we're going to go for a new page. Okay, right. Okay, now that we mentioned now, what's the next thing that we know? What else can we say? Now we know those angles there. Okay, so that's 44, that's 34. What else can we say that we know about this particular question? Okay, folks, in order for us to work out this angle here, which is BDC, so we need angle BDC. So in order for us to work that out, we need to know angle BCD. So we need to know angle BCD. Okay, and then we could work out that one. Now, so what I want you to concentrate on now is this top triangle over here, the BCD triangle. Now, what do we know about cyclic quadrilaterals? Go on.
The opposite angles are equal.
Okay, that's right. So this angle here, this angle here is, and this angle here are the opposite angles of a cyclic quadrilateral. Cyclic means it goes around in a cycle like this, inside the circle. The opposite angles of a cyclic quadrilateral add up to 180. So we need to make that statement first of all. Over here, let's go to, okay, let's go to a brush. Okay, right. So we can say, so we say here, angle, which one would you say? BCD, yeah? BCD. Angle BCD is equal to, what's angle BCD equal to? What's 180 minus 78? 180 minus 78 gives us 102. So you're making that statement, angle BCD is equal to 102 because, okay, opposite angles of a circular quadrilateral add up to 180. And then what we can do here, after you made that statement, we've given the angle, we can put a little note here of what our actual calculation is. So 180 minus our 78 is equal to our 102. That's where we got our answer from. And that's explained there. We've done that beautifully. Let's put that number on there. So let's go back to here. Let's get our blue. So that angle there is now, what is it? 102. We just worked that as 102. Okay, we're going to make another statement now. Let's go back to the paint program over here. Let's change our color to, okay, let's change it to that. Now, if you look at the triangle BCD, what can you tell me about the triangle BCD? Angle B, what do we call it there? BDC. Yeah, angle BDC, this one here, is equal to what? Is equal to 180 minus also, isn't it? So what we're going to say there, so let's write that down. So now we say angle BDC, which is this one over here, the other one we're trying to work out, BDC is equal to, what is it equal to? What's 180? I'm going to do that in a bit, do the calculation in a bit. What is angle? What is this angle here? If I do 180 minus that, what does it give me? What is the actual value? What is it? It's equal to 44. So angle BDC is equal to 44. Y is equal to 44. So what's our explanation? The angle sum of a triangle. So let's write that down. So angle sum of a triangle. Okay, and what we can do, what triangle is it? We're talking about BCD in this particular case. Angle sum of triangle BCD is 180. Okay, therefore, angle BDC, what we just said is 44, is equal to 180 minus 34 minus 102, and put that in brackets. That's our calculation for that. So we now know by calculation that this angle here is, this one here is 44. We nearly finished that question. So we've done all the mathematics, and now this particular question, they're giving you how many marks? 5 marks. Sorry about it being long-winded, but that's what they want in the exam. They want you to explain each step of the way. So now that we mentioned that, so here comes the last part now. Okay, new. Right. What can we say now? We can say here now, angle, which angles? Angle CDB, this one here, this one, angle CDB is equal to angle ABD, which is here, ABD is that one there, which is equal to 44 degrees. Okay. Therefore, they are, what's the key word that we said this proper maths? They are alternate angles. Making what they wanted us to show in the beginning, AB, making line AB parallel to line CD. Whoops. Done. That's another question. copy all that down.